Hello and welcome to the first video of the channel That's Not How It Works. Have you ever watched something and encountered something so ridiculous that you had to continuously shout, "That's not how it works! No! That's just not how it works!" Well, a situation like that happened to me recently, and this gave me the idea for this channel. So in this channel I want to discuss scenes from movies or series that just don't work out. And I will tell you why. And since I'm a physicist, I will mostly do this from a physics point of view. So let's get started with the scene that gave me this great inspiration. It can be found in Star Wars Resistance Season 1, Episode 16, The Core Problem. In this scene, Cass and Poe enter a system in the hope of finding information about the First Order. They find that the system's star vanished and many planets were destroyed by someone trying to dig a hole through them. This was clearly a test site for building Starkiller Base. You know, the superweapon that sucks in half of a star without destabilizing the star and then concentrates all that mass in the planet core without causing the birth of a neutron star or a black hole and then shooting a huge laser that can split up with super light speed to destroy planets in another system? But we're not discussing that one here now. Maybe in another video. So Cass and Poe find a planet into which the First Order successfully dug a tunnel without destroying it. They decide to check it out and fly towards the hole. But what is this? Why are all those rocks just floating there? What about the gravity of this whole planet? Just because a planet has a hole doesn't mean it loses all its gravity. Only at some point within the hole, the two suddenly encounter a gravity well, which only acts on the ships and single rocks, but not the rest of the rocks? What? Even if there's some sort of gravity-changing device inside the planet, gravity doesn't choose which object it applies to or not. That's just not how it works. Let's check it out. This sketch represents our planet with tunnel. We assume that the tunnel is exactly in the middle of the planet and very thin, so perpendicular to the tunnel, there's always the same amount of mass on each side around an object within the tunnel. This means that we only have to take the direction along the tunnel into account, so we have a one-dimensional problem. Here's our coordinate system. The top opening of the tunnel lies at lowercase r equals the planet radius, which is the capital R, and the bottom opening at lowercase r equals minus capital R. The zero in our coordinate system corresponds to the location of the center of the planet, which is also the center of its mass. Gravity always points towards the center of mass of an object. This means that an object above the center of mass gets pulled downwards, whereas an object below the center gets pulled upwards. An object would only float if you would put it exactly into the center, because there is equal mass surrounding it in all directions, negating the gravitational pull. Let's assume we drop an object into the tunnel from the top. There, the potential energy is at its maximum, because this is the furthest the object will be away from the center of mass. And the kinetic energy is zero, because initially the object is not moving. As soon as we drop the object, it is accelerated by gravity towards the center of the planet and it builds up speed. The potential energy is converted to kinetic energy. By the time the object reaches the center, it builds up lots of kinetic energy due to its speed. The potential energy is zero because in this point there is no gravitational pull. However, due to the kinetic energy, the object overshoots this equilibrium point until it converts all its kinetic energy back to potential energy. And since this is a very symmetric problem and the total energy stays constant, the object will only stop at the bottom opening of the tunnel. There it will be accelerated towards the center again and we get a pendulum. A planet pendulum. If we throw an object with an initial speed higher than zero into the tunnel, it will be first accelerated, then decelerated the same amount, and it exits the tunnel at the same speed it entered it. As long as this speed is lower than the escape velocity, the object cannot escape the gravity of the planet and we still get our pendulum. Only if the initial speed is higher than the escape velocity, the object will never return to the planet. So let's take a look at this scene again. Ugh. The circular motion of the rocks is fine, since this is just another pendulum motion because of the horizontal extent of the tunnel. But they should not just float there. That's not how it works. Thank you very much for watching my first ever YouTube video. Please feel free to leave any kind of constructive criticism in the comments below. Thank you and see you next time.